Did you know that almost everyone, anywhere and at any time, did a mistake or error during their height measurement? Welcome to the future of height measurement. Introducing the digital height measurement device by ELUTech. And the people working with us is...
My name is FAISZUDDin bin Muhammad NASIR. My student ID 2022628225.
My name is Tengku Ahmad ASHRAF. My matrix number is 2022616874.
My name is Muhammad IZZUL HAZIQ bin MAZLAN. My student ID is 2022496912.
Hi, my name is Muhammad RASHDAN bin Abdul Rashid and my matric number is 2022624782.
An Arduino height measurement device with the use of passive infrared PIR, which measure a person's height when they are below a sensor. This device is intended to measure people's height accurately. After receiving the signal from the sensors, the Arduino board processes it in order with the software that is loaded onto the board. The application can also be used to manage and store the output data from the devices, such as an LED screen that shows people's height. Now let's get to the objective. Why do we create this device? First of all, it was for presence detection, to ensure accurate detection of an individual presence using the advanced sensory technology. Secondly, it was for measurement calculation. We are trying to achieve the most accurate height measurement calculation through the use of advanced sensory technology and a smart board. Last but not least, it was for readability, usability, and reliability. The first one is to develop a device that is easily readable for users of all age. Second of all, to design a portable device that simplify operation and enhance user experience. The last one is to ensure the device consistently provides the reliable measurement under various circumstances conditions.
So next, I will explain the technique used for our innovation. Let's begin with the component we use for our device. So the first component we use is a Maker Uno X. Maker Uno X is a mini controller board based on the ATmega428, similar to Uno, used to build wide type of projects. The second component we use is a Bluetooth module HC06, a Bluetooth module for wireless communication, allowing the device to exchange data over short distance. The third component we use is HCSR04 ultrasonic sensor. This ultrasonic sensor can measure the distance by emitting and receive the sound wave with a minimum of 2 cm and maximum of 400 cm. The next component we use is a 4-in-1 MAX2710 dot matrix display module. This display module using the MAX2710 for 8x8 LED display, ideal for displaying text or the graphics. So next, I will using the breadboard, a usable board for building and testing circuit without solder the wire connection. So next component we using the jumper wire, male to female and male to male. Jumper wire is a flexible wires used to connect between the components, including to the connect with the main board. A casing is a house to store the component to ensure all components safe. So this is our schematic for our circuit. So I will highlight the main connection only. So let's start with the first one, is Bluetooth module. The 4-pin TSD is connected to pin 3 of the Maker Uno X, and for the pin SD is connected to pin 4. And the second component, HCSR04 ultrasonic sensor for the trigger button is connected to the A0 on the Maker Uno X, and for the anchor pin is connected to the A1 on the Maker Uno X. And the third component, 4-in-1 dot matrix display module. For the CS pin is connected to the pin 10 on the Maker Uno X. For the pin DIN or data is connected to the pin 11 on Maker Uno X, and for the pin CLK or clock is connected to the pin 30 on Maker Uno X. And the last one is a breadboard. For the pin GND is connected to GND or the Maker Uno X, and the 4-pin power or 5V is connected to the 5V supply on the Maker Uno X.
And now I will show you how to demonstrate the digital height measurement device. First of all, we need to turn on the device and after the device is turning on, we need to pair it to the computer. So we need to click the device name and pair it. After that, we need to enter the Google Sheet link to make sure the data of the user that use our device been saved in there. So here our data submission form. For the head, it will appear after the user use our device, and we need to enter the name of the user, the class and the data of the user. After it complete, we can submit the button. So the user need to stand below the device, and the sensor will scan the device, and the LED light will show the head of the device. After submitting the form, the information about the user will appear there: the name, the class, the data and the user head. And now we will try for the second user. So the second user will stand below the device, and the sensor will scan the user, and the LED light will show the user head. And after submitting the form, the information and the head about the user will appear there.
So the last part, I will explain the coding for our device. So let's start with the part by part. So for the first part, these parts include the necessary libraries for controlling the dot matrix display, SPI communication and Bluetooth communication. It accesses the hardware configuration for the display, define the scrolling effect and alignment, and assign pin for the ultrasonic sensor. For the second part, these parts define the global variables for handling the height measurement and Bluetooth communication. The setup function configures the sensor pin, initialize serial communication for debugging and Bluetooth, and start the dot matrix display. So the next part of coding is the loop function repeatedly measure the distance using the ultrasonic sensor. If the distance is greater than 80 cm, it display the height on the dot matrix display. Otherwise, it calculate the height, convert it to string and display it. The height data is also sent via Bluetooth. And the last part of coding, the measure function trigger the Bluetooth sensor to send out the pulse measure the time it takes for the echo to return, and calculate the distance based on the pulse duration. This distance is then used in the main loop to determine the height.
For the discussion, one significant challenge was ensuring the consistent power supply. Using a power bank as the power source offer portability but require careful management to ensure the system remain operational. Regular monitoring and timely recharging of the power bank are essential to avoid interruption in the system's functionality. Another lesson learned was the importance of the sensor of the device. We make sure the sensor below the device is accurately the same, so there is no problem when measuring height. Another limitation that was noted was that the height of a man had to be below 200 cm in order to be scanned by the system. Users have to make sure that they have to be right in front of the gadget for the scanning of their height. Though this requirement may seem rather easy to fulfill, it may be rather difficult in areas with high traffic or density, as the positioning needs to be rather accurate. For the conclusion, the digital height measurement system has been demonstrated to be efficient, convenient, and suitable for height measurement across various use. Application of the complex of advanced sensor, convenient affiliation LED display, automated data storage in the database prove its versatility within medical service, educational institution, and industrial surrounding. Nevertheless, the activities performed in the framework of the deployment and testing of the system showed certain constraints and future research direction. Issues that have to be worked upon include power supply, where the device relies on a power bank, the ability to measure height up to 200 cm only, and the positioning of the user directly beneath the device. Besides the reinforcement of the casing of the system and the durability of the function of the sensor depending on the status of the environment is important in prolonging its usefulness.
That's all from us now. If you have got any question, just comment down below and we will try our best to answer your question. Remember, precision in every measurement, innovation in every step.